Hi, folks. My name is Carl Goodwin, and I'm a senior scientific consultant at Bioteam. And today I'll be sharing some thoughts that I have about scientific data and metadata in the context of AI models. Whether training a new AI model or running an existing model, your data has important context that needs to be provided. This context is usually recorded in the form of metadata, but it goes beyond the normal technical data schema, things like column names and data types. It includes things like descriptions and definitions, how the data was coded, even things like experimental conditions can and should be captured and provided to your model. But the trick is, how is this done technically? You need some systems, you need some schemas in place that are capable of handling this metadata without being overly burdensome to create or maintain. At Bioteam, we've been learning more about this concept of data elements. Data elements are a standardized method of storing information about the underlying meaning and concepts behind data, and they've been around long enough that they even have an ISO standard if you really want to get in that deep. While data elements themselves may seem to be an effective solution to this problem, the challenge still is to find a system that manages them effectively. How do you define your data elements? How do you ensure, or at least encourage that data elements are captured when data is registered? How do you propagate those data elements to downstream derivatives of data? How do you make sure that they're available for reuse? And finally, how are they actually used in the context of machine learning? Those questions have been some of the motivations we've had for building a brand new data management platform that we call Delphini. Delphini was specifically designed to have first-class, easy-to-use support for data elements and to ensure that those elements are maintained through data transformations. Delphini was developed originally for the NIH to help them build a data repository for data related to minority health and health disparities. And one of their key goals was to support bringing together diverse data from many different contributors in a way that promotes reusability and interoperability. We're now moving forward towards a private beta offering of this software. So if this sounds like it would help you with any of your current challenges, please get in touch. Since we've been building this data element focused data platform, one of the things we've been really curious to explore has been whether we can build an MCP or Model Context Protocol server that integrates with Delphini to provide this deep level of metadata to off-the-shelf LLMs in order to help them make better inferences about the data you have and what it means. This should help, for example, when chatting with the bot about searching for certain types of data in a large repository, or in the case of this screenshot, asking the model to generate some candidate data visualizations through automated code generation. As a next step, we also want to explore the ability of the LLM to help users with creating data transformation code. Delphini already has integrated support for performing data transformations, but users must set up the transformations themselves. If we can find an effective path for the LLM to take a user's prompt and automatically generate candidate data transformation code, the user can review it and the resulting output, potentially only requiring minimal tweaks to achieve their desired result. We're optimistic about the future of metadata in scientific data repositories, and we'd love to have the opportunity to chat with you further about these ideas. Thanks.